Hi, this is about non-parametric alternatives to parametric statistics. Why is these non-parametric alternatives? Because we basically want to have performed the parametric statistics, but when we have like inevitable conditions, then as alternatives we may consider non-parametric statistics. And in design research, we have often the situation that we better choose non-parametric for proper analysis. So let's learn about these non-parametric statistics, which are the alternatives to the parametric statistics. And this is Korean paragraph has been written by myself, and I found that this would be helping you understand why we call that parametric in Korean as mosu. Okay, so coming back to in English, parametric versus non-parametric statistics have distinction in terms of the sample size and how the data distribution is shaped and how the data set has been measured. So parametric statistics assumes that the data has come from a type of probability distribution and makes inferences. So referring that there is normal distribution data set. So the parametric statistics infer that original normal distribution. But non-parametric statistics don't need to assume that normal distribution. Okay, so that makes inferences about the parameters of the distribution, such as a normal distribution, whereas non-parametric statistics does not. Okay, so parametric statistics are having most of the inferential statistics we know, including independent sample t-test, paired sample t-test, and ANOVA test, and the correlation analysis. And on the right column, I have listed up the non-parametric alternatives to each of the parametric statistics. So if your data set are not adequate for parametric statistics, and you are planning to perform the independent samples t-test, then instead of this, you may consider, and sometimes you better consider taking this Mann-Whitney U test as a non-parametric alternative to the parametric statistics. And this way, Wilcox signed rank test is corresponding or counterpart of the paired samples t-test, and Kruskal-Wallis test is for one-way ANOVA, and repeated measured one-way ANOVA has a Friedman test as the non-parametric alternatives. So if you are fluent in choosing inferential statistics, then naturally you will have a quick match between parametric and non-parametric. If you're the first time to hear about this, then take a note and simply memorize the matches here. Okay, so why am I talking about this? Because taking the non-parametric alternatives has advantages, but also it has limitations. Firstly, the advantages, one of the advantages of the non-parametric statistics is that it is useful when you have very small samples. And by convention, when your sample data is smaller than 20, so you have recruited 15 people because it's a brainwave testing, so it was difficult to recruit many people, or you have been interviewing 10 CEOs, and technically it was almost impossible to recruit more than 20 CEOs. So for inevitable reasons, you may have relatively small samples. Then you better take non-parametric statistics. And secondly, you don't have to assume that the shape of your data distribution is a normal distribution. This means that when your data do not fit a normal distribution, such as M-shaped or it's gradually increasing, so it's not a inverse shape of the Gaussian distribution, Gaussian curve, then you should consider the non-parametric statistics. And when your data have no clear numerical interpretation, such as when your data are measured on nominal or ordinal scales. Still, depending on discipline, but majority of discipline accept the interval scales as the good numerical or acceptable numerical interpretations. So if the size is big enough, then in my understanding, when you publish your research in social science domain, then you may take the parametric statistics for the analysis. But in some discipline, treating your intervally measured variables should be included as no clear numerical interpretation, then maybe your reviewer will claim that you should have applied non-parametric alternatives instead of the parametric statistics. So it sounds great, right? But it has limitations. Firstly, these non-parametric statistics are less sensitive than parametric statistics. Therefore, you may fail to detect differences between groups, or you may fail to detect any changes, statistical changes, although maybe there is a change. So it's less sensitive. And second, if you have the right sort of data, like is sufficiently big or has been measured in a continuous scale, like interval or ratio, or your data distribution is fitting a normal distribution, then it's always better to use the parametric statistics. Then you may be curious, like, well, my data distribution is not exactly Gaussian curve, but it's not very much different from Gaussian curve. How can I judge whether it is fitting a normal distribution or not? For this reason, you can perform the normality test. And this statistics is telling you whether this difference, or like this green histogram and this nicely drawn red line, is statistically different or not the same, but statistically not different. So this KAIST method or Shapiro-Wilk test is telling you their results. So a normality test is used to determine whether sample data has been drawn from, taken from a normally distributed population or not. And when it is not statistically different, so when the when the significance value is bigger than your alpha level, then we conclude my data distribution is not different from normal distribution. And when we do this testing, then usually we wish to have the normal distribution, right? So we are expecting that big p-value here, because big p-value tells me that my data distribution is not different from the normal distribution. Okay, if you are not used to this testing, then it may confuse you. But please try to keep that in your mind. Previously, I told you that it's actually depending on the discipline. And if you submit your work in a kind of very stringent field, then your inferential statistics or parametric statistics will be very carefully checked whether your measured scale or your metrics are really ratio-based. In design study, we frequently adapt this Likert scale, which is actually adapting the interval scale, right? And regarding this way of surveying, statisticians may claim that, it's no clear numerical interpretation. And social scientists may say, psychological distance is almost equivalent to the numerical quantity. So this person will not apply parametric statistics for intervally measured data, but this person will be likely to use the parametric statistics for intervally measured data set. Designers? So as a design researcher, if you are submitting your work where there's a lot of engineers or more than engineers, these statisticians are gathering, then you better not applying the parametric statistics for intervally measured data. But if you are submitting your work to KAI or design community, then it's widely accepted that applying the parametric statistics to intervally measured data set. So in this testing, each farmer, Wilson, Tom, Alfred, has 9 watermelons, and their bricks data are listed here. So 9 watermelons, 9 watermelons, 9 watermelons. And you want to compare the averaged bricks across the farmers. So it's one way ANOVA situation if the data set is adequate for the parametric statistics, but it is not. So what was the non-parametric alternative to one-way ANOVA between group test? Yes, the Kruskal-Wallis test. All right, so in SPSS, you choose under the analysis, you choose non-parametric tests, and here under the legacy dialogues, then K number of independent samples. In this case, 3 independent samples, 3 farmers. Okay, so the grouping variables has been declared between 1 to 3, and then as a result, Kruskal-Wallis test yielded the result like farmer number 1, 2, 3, and each of them had 9 watermelons, 9 watermelons, and 9 watermelons, and their average bricks has been estimated as mean rank here. And this Kruskal-Wallis was testing whether these mean ranks are statistically different from each other, and the significance value is bigger than 0.05. So from the Kruskal-Wallis test, we may conclude that the average bricks scores across 3 farmers are not statistically different. So in my opinion, these non-parametric alternatives are useful, especially when you have a small group of participants in your study. And in design discipline, we often carry out explorative studies, and you recruit some people for FGIs or interviews. And due to the time limit and the fund limit, it's difficult to recruit more than 20 people. So its sample size is small. And also, when people are expressing their opinions, then it's often difficult to expect the normal distribution of the data set. And also, although it's less sharp than parametric statistics, in design research, it is maybe sufficiently good enough to read the tendency through the non-parametric statistics rather than very sharp statistical analysis. So in my experience, in design research, these non-parametric alternatives are especially very useful for practical reasons. Thank you.